Sergio Pérez just drove a Ferrari-powered Cadillac in total secrecy, and what the engineers discovered left the garage in complete silence. Yes, this wasn't a casual test. Checo hit lap times that nearly matched modern qualifying pace in a 2-year-old car, on cold hard tires, with no setup. But here's the shocking part: the data revealed a critical flaw in Cadillac System 1 that could lead to race-ending failures if left unresolved. And now, with just months before their debut, Cadillac may be forced to redesign everything, unless Checo's warning was heard in time. Sergio Pérez arrived in Imola not as a Red Bull driver, not as a former podium finisher, but as the test spearhead of a brand new Formula One operation, Cadillac Racing. No cameras. No interviews. Just a cold, gray track, a 2-year-old Ferrari SF23 stripped of all branding, and a garage filled with engineers from two worlds, Detroit and Maranello. What followed wasn't a test. It was a revelation. And what the data showed was more serious than anyone expected. From the first laps, something felt off, not wrong, but extraordinary. Checo, out of F1 action for nearly a year, was lapping with surgical control, even in suboptimal temperatures and full fuel loads. But it wasn't just that he was quick. It was the way he was quick. No lockups. No oversteer corrections. No radio panic. Just clean sector after clean sector. On day 2, he produced a lap that triggered silence in the garage, a 1 minute and 17.27 seconds on hard tires. For reference, that's within 3/10 of modern free practice pace, done in a mule car not built to perform. That lap forced the team to stop. Literally. Mechanics backed away from the car. Ferrari engineers rechecked tire pressures, telemetry lines, throttle traces. Was something miscalibrated? Was there a tailwind? Was DRS somehow left open? No. It was all correct. That time came from pure driving. And that's when the tone shifted from curiosity to concern. Because if a 2-year-old car could get that close to current pace, what did that say about Cadillac's simulation data? What had they missed? Then came the serious discovery. Pérez's pace had come at the edge of tire safety windows. The car was operating at temps that, under colder conditions or lower grip circuits, could drop into dangerous thresholds. The team realized they had underestimated cooling exposure in race-length simulations. Had this gone unnoticed, it could have led to tire deflation mid-race, brake lock, or worse, catastrophic component failure. That wasn't theory. It was now logged data. And it took Checo's unique driving rhythm to expose it. This wasn't just Checo setting a good time. It was Checo saving a billion-dollar race project from walking blind into technical disaster. His consistency allowed engineers to compare baseline models to live telemetry, and the mismatches revealed gaps in tire modeling, energy recovery behavior, and brake-by-wire cycling. For a team months away from their first car build, that kind of insight is not optional. It's foundational. And Checo provided it all without drama, without a single driving error, and without asking for attention. In late October 2025, the world was watching the championship fight between Red Bull and Mercedes. But in a quiet corner of northern Italy, something far more foundational was taking place, something that didn't make headlines, yet may define the future of Formula One's next era. General Motors had reserved Imola for 2 days. The goal? To test not just a car, but a complete operational model for their 2026 Cadillac F1 entry. This wasn't a show run. It was a live systems rehearsal with pressure, timing, data flow, and one very experienced driver at the center of it all. The car they used was the Ferrari SF23, legal under FIA's testing of previous cars, TPC, regulations, meaning it was exactly 2 seasons old. Outdated in aero, less refined in suspension, and slower than current machines, but perfect for what Cadillac needed. They weren't interested in lap records. They were interested in team rhythm. Could their new engineering group, many of whom had never operated under Grand Prix conditions, execute procedures with the discipline required at the elite level? That's where Checo Pérez came in. For Cadillac, selecting Pérez wasn't just about getting a skilled driver. It was about embedding experience deep into a team with no F1 racing history. Checo didn't need to adapt to the SF23. He knew its DNA. He had raced against it for 2 full seasons. His task was to not just drive it, but to use it as a diagnostic instrument. His every lap would expose weaknesses not in the car, but in the structure Cadillac was building around him. Inside the garage, things were anything but casual. 25 Ferrari engineers had been assigned to oversee the operations. They didn't just provide technical support, they provided accountability. Fuel flow data was reviewed in real time. Tire blanket timing was rehearsed to the second. Every system from pit lane radios to garage cooling was logged, graded, and scrutinized. Cadillac's team wasn't being trained. They were being evaluated. And the benchmark they were chasing? was set lap after lap by a calm, focused, and brutally precise Sergio Pérez. The test wasn't random. It was scripted like a Grand Prix weekend. Day 1 replicated Friday, installation laps, long runs, basic setup trials. Day 2 shifted into Saturday and Sunday simulation. That meant qualifying prep, pit stop rhythm, live tire changes, and full race stints. Checo didn't just comply, he elevated the entire process. His feedback was minimal, clear, and actionable. Engineers described it as calibration-level input. He wasn't guessing. He was teaching by driving perfectly repeatable stints that allowed systems to lock into sequence. Over the course of 2 days, Checo Pérez drove 190 laps around Imola, nearly 950 kilometers of precise, uninterrupted performance. From the outside, those numbers seem like simple endurance. But from the inside, what the engineers saw was far more complex, a driver hitting repeatable performance targets under controlled yet demanding conditions. His baseline run? A 1 minute and 18.72 seconds on cold hard tires in low-grip air. Solid. Controlled. Conservative. But what came next was a sharp escalation in what this test would reveal. By midday on day 1, Checo was already closing in on competitive pace, something the engineers had not expected. He brought the lap time down to 1 minute and 17.87 seconds, still on hard tires, with the car in high-fuel race trim. For reference, that put him within striking distance of some 2024 free practice 1 times at the same circuit recorded by current factory drivers on far softer compounds. But Checo wasn't pushing for glory. He wasn't even on a time attack. He was running race stints with surgical consistency. And the data didn't lie. The most alarming metric came from tire degradation. Over several runs exceeding 20 laps each, Checo's average pace drop was just 0.12 seconds per lap. That's a number you typically associate with top-tier race management during actual Grand Prix Sundays. It means the car remained balanced. Tires stayed in temperature. Load transfers were smooth. Brake temperatures didn't spike. There were no sudden grip cliffs. That kind of stability is almost never seen during a simulation and almost never comes from a test car in the hands of a driver who hasn't raced in months. Telemetry showed exact steering angles through Piratella and Rivazza. There were no sharp corrections. Just fluid input, identical across multiple stints. In turn 7, throttle application was so consistent that engineers used Checo's traces to recalibrate the torque maps for future software updates. Brake wear rates? Minimal. Fuel consumption data? Predictable. The message was clear, the car was stable because the driver was flawless. He wasn't chasing lap time. He was giving engineers clean laps, and clean laps are where you find true insight. And then came the standout number, 1 minute and 17.27 seconds. That was the best lap of the test, set on day 2, again on hard tires, again with fuel on board. No DRS. No slipstream. No low-fuel qualifying tricks. That time immediately became a reference. It was only 0.3 off what Charles Leclerc had done in free practice 1 at the same circuit in 2024 with soft tires and a far more advanced chassis. And this wasn't a one-off. Pérez's entire run that day was within a half-second window, lap after lap. Stability at that level doesn't just impress. It instructs. For Cadillac, this was more than just telemetry. It was validation. Their car model wasn't ready. Their team was still in rehearsal mode. But in Checo, they had a constant, a driver who could turn laps into strategy, and speed into data clarity. He gave them the benchmarks they didn't know they needed. Not by driving faster than expected, but by being more consistent than simulation software had projected. That's the kind of data you can build a team around. And Pérez didn't ask for a single adjustment. He simply delivered. Quietly. Efficiently. Completely. This test wasn't designed to break lap records, it was built to expose weaknesses. Cadillac didn't bring Checo Pérez to Imola to impress the public. They brought him to stress test every system that will power their Formula One entry in 2026. From tire heat profiles to pit lane radio delay, every aspect of race day operations was on the table. And the Ferrari SF23? That wasn't just a test mule, it was a benchmark tool. A known quantity with predictable behavior, perfect for diagnosing how a brand new team handles high-pressure execution. To comply with FIA regulations, the SF23 was selected for its 2-year-old status eligible under the TPC, testing of previous cars, clause. But this wasn't a garage leftover. Ferrari delivered a meticulously prepared chassis, complete with a core support crew of 25 race-seasoned engineers, many of whom had worked on Grand Prix weekends with Leclerc and Sainz. Their job was clear: ensure the car performed to spec and track whether Cadillac systems could match the discipline of a factory team. The test plan Cadillac presented wasn't amateur. It followed a complete race weekend template. Day 1 imitated Friday, shakedown, setup validation, data correlation. Day 2 was split between qualifying simulation protocols and full race scenario drills. This wasn't just about what happened on track. It was about garage communication, radio protocol efficiency, tire swap timing, pit stop choreography, and response speed when things changed in real time. Cadillac wasn't rehearsing lines, they were putting on a full dress rehearsal, with every failure point visible. And then came the variable that made it all work, Checo Pérez. His pace was remarkable, but his true value was his control. His ability to maintain lap-to-lap consistency gave engineers clean data, and clean data meant Cadillac could isolate procedural inefficiencies from car-related variables. If the car was stable, and Checo was exact, any remaining noise in the system had to be operational. This allowed Ferrari and Cadillac engineers to isolate timing delays, diagnose internal workflow issues, and recalibrate pressure targets across race stints. Checo didn't just deliver lap times. He delivered clarity. When the car suffered a minor sensor sync failure mid-run, Pérez compensated, manually adjusting shift points and lift and coast profiles to protect battery temperatures while waiting for diagnostics to realign. That moment wasn't broadcast. But inside the garage, it proved everything. A driver who could improvise within system parameters, without compromising data integrity, was more than a tester. He was already acting like a team leader, not just surviving the simulation, but enhancing it.